Our learning goal for today, we have two of them, working with parallel lines. I can identify equations of parallel lines. I can write an equation to describe a line parallel to a given line. So those are the two different things that you need to make sure that you're getting an understanding of from this lesson. So let's think about parallel lines. What does parallel mean? If we have something that, if we have parallel streets, we have parallel lines, we have parallel anything. What are we saying? Lindsay? They'll never touch. They'll never cross. They'll never meet. Okay. So when we think about parallel lines, and we know that every line has a slope, every line has a y-intercept, every line has several other points on it. What do you think we could say about two lines? For them to be parallel, what do you think would have to be true about their slopes? What would they have to do? They'd have to be the same. Why? Why do you think they'd have to be the same? What's happening in slope? What's happening in slope? Slope is made up of what? What's another name for it? Rise over run. Thanks for showing up today, Austin. Rise over run. So if they're parallel, Austin said they have to have the same slope, which is rise over run. And so then in reality, they have to rise and run at the same amount, because if they don't, eventually they would end up running into each other. So we have to have lines with the same slope, first of all, for them to be parallel. They have to rise and run at the same rate. But what do they have to have that's different? Y-intercepts, yeah. They have to have a different y-intercept. Each of them have to have their own y-intercept. They cannot share one, because if they share one, then they have a point in common. They can't have a point in common. Okay? And then a vertical line is parallel to another vertical line. With a different what? No, that one I have to say no to, sorry. Let's think vertical lines. Do they have to have a y-intercept? X-intercept, yeah. With different x-intercepts. They have to cross the x-axis at different places. Horizontal lines can have a y-intercept, so they have to have different y-intercepts. But vertical lines, we can't even talk about their y-intercepts. We have to talk about their x-intercepts, okay? So those are the things that are going to help us decide when lines, give an equation when lines are parallel, okay? So what you're going to do is you need to identify, so that you can tell just from the equation, you need to identify the slope and you need to identify the y-intercept. You do not get to come back tomorrow with assignments where you just say these lines are parallel, because they have the same slope and different y-intercepts. Yes, that's the definition, but you have to prove it. You have to say, okay, well, here's the slope of this one, here's the slope of the other one, here's the y-intercept of this one, here's the y-intercept of the other one. Okay, so y equals 6. What is its slope? What kind of a line is that, y equals 6? Anybody know? It doesn't have an x value. Which means, first, Riley, a vertical. Okay, let's turn on those graphic calculators. Let's put it in. So y equals, clear out what's in there. Just type in 6. Because it's y equals 6. Press graph. What do you get? A horizontal. What kind of slope does a horizontal line have? 0 slope, which means that it's 0 for m. If you take 0 and put it in for m would be 0. 0 times x is what? What is 0 times x? I don't care what x is. What's 0 times x? It's 0. And 0 plus 6 is 6. So remember, when there are no x's in the equation, you need to get this planted. It's not going away. When they're occupying with graphing calculators, you're done. When there are no x's in the equation, that means we have a zero slope. That means it's a horizontal line. What's its y-intercept then? If it has a slope of 0, what's its y-intercept? 6. Every point on that line has a y value of 6, so it has to cross the y-axis at 6. Okay, y equals 6x plus 5. Y is by itself, it's in slope-intercept form. It's ready for us to identify the slope and the y-intercept. So what's the slope of this line? 6. What's its y-intercept? 5. Colin, would you join us, please? Y equals 6x minus 7. Is that in slope-intercept form? Yes, it is. Okay, what's the slope of that line? 6. And what's its y-intercept? Negative 7. Now, in your homework, you can take shortcuts. You can call slope what? M, and you can call the y-intercept B. So you can say M equals B equals. Y equals negative 8. What kind of line do we have here? Horizontal line. What's its slope? 0. And its y-intercept is negative 8. Okay. Now that we have done the identifying of the slopes of the y-intercepts, we can now determine which of those lines, which of those equations represent parallel lines. So, which ones do you think are parallel?
1 and 4.
The first one and the last one, so y equals 6 and y equals negative 8. Okay, go ahead and in your graphing calculator, put in into y sub 2, leave the y sub 1 there. And now for y sub 2, put negative 8. And press graph. And if both lines don't show up, do a zoom 6. Okay? You should have 2 lines on your graph now. Are they parallel? Okay, because they're both what kind of lines? Horizontal lines. So horizontal lines have to be parallel too, don't they? So we're going to say that y equals 6 and y equals negative 8 are parallel. Anybody happen to know the mathematical symbol for the shortcut way of writing parallel? Are parallel? In case you want to use it, because remember you could use M for slope and you could use B for y-intercept. If you don't want to write, the word parallel, anybody happen to know it? Well, then I guess we don't get to use it. Darn. Okay, are there any other pairs of parallel lines? Any other lines that are parallel here? No? The second and the third one should be because they both have what? Slope of 6, but they have y-intercepts, don't they? So let's go ahead and let's verify that with our calculator first. What are your y equals screen here? Will you take out those horizontal line ones, your 6 and your negative 8? And will you type in 6x plus 5 in one of them, and 6x minus 7 in the other? Hayden, join in. I'm asking everybody to do this. And again, press graph. If 2 lines do not show up, do a zoom 6, then they should. So we are think right now, we are saying that y equals 6x plus 5 and y equals 6x minus 7 are parallel. And you're verifying it with the graphing calculator, are they? Okay, what are both of these lines doing? What is their behavior? They're rising from left to right, because why? What's the reason? Positive slope, yeah. Okay, go ahead and write on your note paper now. Here's another answer for this problem. We have two sets of equations that represent pairs of parallel lines. We have our y equals 6 and y equals negative 8. They're a pair of parallel lines. We have y equals 6x plus 5 and y equals 6x minus 7 that are parallel. So you're going to be doing some of this in your homework. So we just actually did problem number 2 on page 297, and notice in your homework you're doing on this page. So when you do your homework, this would be a good reference. Okay, number 3. We have 4 equations here. We have y equals 3/4 x minus 1, y equals negative 2x. we have y minus 3 times equals 3/4 times x minus 5, and we have 5 minus 4 equals negative 2 times x plus 2. Now, what do we have to identify from all of those? Slope and the y-intercept. Okay, is the first one ready for us to do that? Y equals 3/4 x minus 1. Okay, so it has a slope of what? 3/4. And a y-intercept of? -1. Yeah. Okay. What's the second one? Is it ready to identify slope and y-intercept? Is it in slope-intercept form, in other words? Yep. So what's its slope?
2, -2.
-2. And its y-intercept is? 0. What do you think? Do you think these two are parallel? No, they have different y-intercepts, but what's the problem? Slope isn't the same, yes. We already know these two aren't parallel. Okay, is the next one ready for us to be able to pull out the slope and the y-intercept? No, you can only do that if, remember, y-intercept, what is equal to 0 in the y-intercept? What is equal to 0 in the y-intercept point? Isn't the x value? So if there was a 0 being subtracted here, we would know the x value was 0, and then we would know that is our y-intercept, but it isn't because it's not 0. So we're going to have to get this in slope-intercept form, which is what we did. We've been doing that with some redos besides. Now, can we add 3 first to both sides to get y alone? No. I don't know why some of you thought you could do that, but you have to do this distributive first here. So let's get busy and do it. Fun. 3/4 times 5. Huh. Without a calculator, see if we can do it. 3/4. 3 and 3/4. Okay. So, can we trust Benton, do you think? How do we multiply fractions without a calculator? 3/4 times 5/1. So 3 times 5 is 4 times 1 is 15/4 is 3.75, also known as 3 3/4. Okay. Now, are we ready to get the y-intercept out of it? Yes. No, it's not in slope-intercept form yet. We got one more thing to do, don't we? What do we have to do? Cameron, what do we have to do? Wake up.
I got this.
Tate.
Add 3.
Add 3. Y is now by itself. And we have 3/4 x. This is like a negative 3 3/4, correct? Add a 3 to it. What do we have?
3/4.
Positive?
Yeah.
Negative 3/4. So, what's our m value? Oh, let's do it. I'm gonna move that because it's a little bit more obvious. Got all kinds of room over here. M equals 3/4. B equals negative 3/4. Okay. Let's get our last equation renamed. Go ahead and do it because I'm trusting that you can handle this. Okay, hopefully you ended up with y equals negative 2x. Did you? Okay, so it has a slope of negative 2 and a y-intercept of 0. Okay, do we have any pairs and parallel lines, or even groups of 3? Maybe there's more than, or maybe all 4 of them are parallel to each other. Do we have any parallel lines here? The second one and the fourth one? So this one right here, I'm going to use a different color. This one right here and this one. Reevaluate that. Look at this equation. Look at this equation. They're the same line. This is that line in point slope form. This is one of the points and that, so from that line. This is the same line. Can they be parallel when they're the same line? No. They have the same slope, but they have the same y-intercept also. They're the same line. It's really just a different name for the same line. So that we can't say those guys are parallel. Are there any? How about that first one? Is it parallel with any of them? Let's see, right here we got this, and we've got this. How do you feel about that? They both have the same slope. Do they have different y-intercepts? They have the same slope, they have different y-intercepts, they're parallel, aren't they? So we're going to say that y equals, and we're gonna give them their original names. Okay, I gotta get it so that we can. So the first one's original name, it was already in slope-intercept form, was what? I gotta go back. -1, okay. And y equals y minus, no, it's not y equals. We gotta do its original name. Y minus 3 equals 3/4 x minus 5. Are parallel. So this is a good place to make a note of caution. Why can't we just tell when they're in slope-intercept form, when they're given in point-slope form, we can see that these two, right away, before we even renamed it, we could see that they had the same slope. So why not just say, okay, well, they have the same slope, not even mess with that and say, they gotta be parallel to each other then. Well, notice what happened. After we got this renamed into slope-intercept form, it ended up being the same line. It had the same y-intercept. We couldn't do that. So we cannot, just because an equation is given to us in point-slope form, say, as long as they have the same slope, these lines are parallel. We have to make sure that they have different y-intercepts. Okay? So any questions? You don't ask me questions, but yet, come tomorrow, you'll be mad at me when I say you're not doing what is expected. Okay, let's look on page 297 in your books. Page 297, problem number 4. In problem number 4, geometry, show that ABCD is a trapezoid. What's the definition for a trapezoid? It's first of all, it's a quadrilateral, it's a 4-sided polygon, but what has to be true for it to be a trapezoid?
Some 4 sides.
Has to have 4 sides, what else? Has to have one set of parallel lines. One set of opposite sides have to be parallel. Can both of them be parallel? Both sets of opposite sides? No, then it turns into a what?
Square.
Square or a rectangle, yeah. So for a trapezoid, it has to be exactly one pair of opposite sides is parallel. So we're going to look at this figure and say which pair of opposite sides appear to be parallel. Which sides? AB, AD,
BC.
and BC. Okay, it appears that line segment AD, that's how we say line segment AD and line segment BC are parallel. So those are the two that we have to prove that they are. How are we going to prove it? They have to have what? Same slope, different y-intercepts. Well, first of all, are they going to have different y-intercepts? They have to, don't they? Because there's no way these two are going to cross at the same point. It doesn't appear. So if we can just prove they have the same slope, we're going to be certain that they're not going to cross at the same place because they're on different places on the graph, right? So show that they have the same slope. That's the only thing we have to prove here. So we need to find, so if we can find the slope of line segment AD, then we're going to be able to compare its slope after we find the slope of the other one. So we need the ordered pair. What's ordered pair for point A?
-2.5.
Okay, ordered pair for point D. It's on your graphs, on your
2, -1.
2, -1. Okay. How do we find slope given 2 points? Yeah, we do the slope formula, don't we? Okay. So M equals. Go ahead and do it. Because you again know how to do this also. When you're done, you can check me out, see if I'm right. Okay, does line segment AD have a slope of -3 halves? Does that match the behavior on the graph? Is the line segment falling from left to right? Okay. Now we'll find the slope of line segment BC. It has endpoints 4, 5, and 6, 2. Go ahead and find the slope of that one. Did you get -3 halves? Okay, so are they parallel? Yes, so we would say that AD, line segment AD, I'm now going to reveal to you the mathematical symbol, is parallel to the line segment BC. We just proved it's a trapezoid. Now, the other thing we could do is we could also try to disprove that A, B, and D, C are not parallel, or that they are parallel, or not parallel, excuse me, because they don't look like it on the graph, but we're just going to go with how it looks. We don't often get to do that in geometry, though. Okay, anybody have any questions on a problem like that in your homework? Okay, then we're moving on to number 23. Which says the directions tell us to do the following. Write an equation in slope-intercept form for the line that is parallel to the given line and that passes through the given point. So first thing I want you to do is I want you to go to your graphing calculators and the y equals, I want you to pair what you have in there, and I want you to put in this y equals 1/2 x plus 5. And graph it.
What are we doing?
So when you put in a fraction, especially since not all fractions are nice decimals, here's how you put a fraction in parentheses, 1 divided by 2 parentheses. Okay. So parentheses 1 divided by 2 parentheses will show a fraction bar that way. Okay. So 1/2 x plus 5. Graph it. What's the behavior of this line? Doing? Should be rising from left to right because it has a positive slope, doesn't it? Okay, now, for us to have parallel lines, so basically what we have here is we have a line on the graph. You just told me here's what it looks like on the graph, right? It's rising from left to right. We need a line that's going to be parallel to that, but yet it's also going to go through that point 4, -3. So 4, -3 is not on our given line. 4, -3 is on another line. So would you look on your graph and tell me, is ordered pair 4, -3, like kind of just eyeball this, and would it be above or below this line? On your graphing calculator, would you look? Ordered pair 4, -3. Would it be above or below? Below. So it's somewhere out here, okay? It's somewhere. So would you draw those pictures right now? Because that's what we're doing. We have this given line that you just graphed, and now we have to find a line that is parallel to it, going through that point that we just put there. So to do that, we need for them to have the same slope, don't we? So what's the slope of this one? 1/2. Well, we're going to identify that because now we're going to take it over here and we're going to say, well, then this one has to have a slope of 1/2. It has to, doesn't it? So now what we're going to do is what we've been doing before. How do we find the equation of the line in slope-intercept form? We don't know what the y-intercept is, but we can actually use, we don't even have to know right now, we can use point-slope form. We can use this point that is supposed to be what the line goes through, and this slope, and we'll write point-slope form. So we'll do y subtract what? -3 equals 1/2 times x minus 4. This is why I had to make you redo that assignment. We have to know how to work with point-slope form. Okay, let's get this put into slope-intercept form now. So this will be y plus 3. The other side we'll do our distributive property. Here I was just cleaning up the minus and negative. 1/2 x minus 1/2 of 4, 2. What are we going to do next? Subtract 3. Y equals 1/2 x, has the same slope. Minus 2, minus 3. Minus 5. Does our new line have a different y-intercept? -5, +5. Would you put that in though? We're going to verify that it really is parallel to it and that it goes through that point. So would you put in y sub 2 now? Put in y equals 1/2 x minus 5 this time. Do they look parallel? Cameron, do this. Now we're going to make sure it's going through that point that it's supposed to go through. So go to second graph, second key graph, and it should take you to a table. I want you to find the x value of 4 in that table. Find the x value of 4. Is the y value -3? We're looking, you're going to have to look in the second column. Look in the second column for the y value, okay? So in the second column, our new equation that we just put in is where the x is equal to 4 in the first column. Skip over a column, is the y value equal to -3? Okay, so we did well. Questions? This is probably what challenges students the most. Understanding what you're doing here. Hearing no questions, we're going to move on to our last problem that we're going to do together. And this is how today and tomorrow are going to be. It takes us a while to go through the notes. You're going to have to do that. That's why you don't have a whole lot of problems to do. Okay, number 33. Our given line is given to us in standard form, not in slope-intercept form. What is it that we need from it again? What do we need from it to carry over to our other one? Slope. So we have to get this in slope-intercept form. So our first goal is to get it solved for y. So let's get that done first. Okay, this is kind of where it breaks down for a lot of us, is when we now have to divide. I am going to strongly suggest that when there is subtraction here, you need to rename it to add the opposite to help you do this correctly. Except I like to also, the other thing I like to do is, I didn't mean to do that, I like to do it to every piece. Some of you like to do what I just wrote, but I like to divide every piece. I like to show that you divide every piece because you really do have to. So this becomes y. 8 divided by 4 is 2. plus negative 3/4. You can't divide 3 by 4 and get a whole number, so we'll just leave it as a fraction. So why did we do that? What do we need? We need the slope. So what's our slope? Negative 3/4. That's what's important, because now we're going to take it up here and we're going to use it with this. We want a new line that has that slope, goes through that point. What would this line do on the graph? We don't have time to put this one in our graphing calculator. What would this one do? Fall from left to right. So we have this line that's going to fall. So really what's happening is we're looking for another line that's going to fall at the same rate, and it's going to go through this point. We don't even know right now where that point is, so we're just going to say it's somewhere. Okay? So now we're going to do our point slope form. Y subtract negative 3, negative 3/4 times x take away 4. This is another really good place to change subtraction to add the opposite. Here, it becomes plus 3, because the opposite of negative 3 is positive 3. Over here, before I even do my distributive property, I'm going to change this to x plus a negative 4. Now I'm ready to do my distributive property. So negative 3/4 x. Negative times a negative is a positive 3/4 of 4. I have $4. I say I'll give you 3/4 of it. $3. Subtract 3 from both sides to get that y by itself. Notice they just happen to use the same given point. Doesn't mean that that's going to be the one all the time. Negative 3/4 x. What happens here? They cancel each other out. We don't need them. Questions? Did you keep up? Would you go to your y equals screen and just clear out what's in there, please? And then turn them off, return them. And you do no graphing in your homework. We just use these basic tools to help us see what's happening. So get out a sheet of loose leaf paper and all of you who did not get a stamp, feel free to come in tonight after school or tomorrow morning before school. That's when you will earn your stamp. I'm done letting you do it during homework time. Caleb, after you have the assignment written down, you can come up and do what we talked about at the beginning of class.